question is, the maximum overshoot can be decreased without affecting steady state error given by option A, proportional error controller, option B, gain adjustment, option C, derivative error controller, option D, integral error controller. See, if we go through the concepts of proportional error controller as well as the derivative error controller and integral error controller, we are going to know the derivative error controller is going to reduce the maximum overshoot but without affecting the steady state error. Hence, option C is correct.
Now, in force voltage analogy, stiffness of spring constant K is equivalent to, it can be of resistance he has given, it can be of 1 by L, that is 1 by inductance, and 1 by C, 1 by capacitance, and one more option given as E, okay, voltage. Okay, now if you see, what is the force equation for mass block? Suppose if you have a mass block, force equation is m into dV by dt, or you can write this one as m into d square theta by dt square. Similarly, suppose if you have one more relation that about friction, okay, it is given as B into dV by dt, okay, and one more force spring constant relation is F is equal to K into theta, okay. Now these are the three relations, that is three blocks we have due to friction, due to mass, and due to spring constant K, okay. Now what he asked, force voltage. There can be two analogies here in control systems, force voltage and force current analogy. This one he has given as force voltage analogy. Many people will think that directly while seeing this question, spring constant K is equivalent to option A R, but we have to check it here, okay. Now let us see here, what is voltage V across inductor? V is equal to L into di by dt. Similarly, voltage across capacitance is 1 by C integral of I dt. Voltage across resistor is V is equal to IR. I can write this one as L into d square Q by dt square. Similarly, this one as 1 by C into Q. Similarly, this one as R into dQ by dt. Now compare these equations here, okay. Force voltage analogy, compare these equations, okay. Now what is spring constant K? Spring constant K is equivalent to 1 by C, okay. Since here I is equal to dQ by dt, I am replacing everywhere I with dQ by dt, okay. Now force voltage analogy, spring constant K is equal to inverse of capacitance, that is option D. Unit circle of the Nyquist plot transforms to 0 dB amplitude line of the Bode plot for. Now what is 0 dB line amplitude of Bode plot? Let us take, you have Bode plot like this. Now this is the 0 dB Bode plot line, okay. Now what is this one? This is nothing but a phase crossover frequency, okay. This is phase crossover frequency. It can be of any value, depends on transfer function. Since in question he has not given any transfer function, because any transfer function you can see in Nyquist plot, it encircles the unit circle, okay. So it depends upon the transfer function. We cannot say whether it is low or high, but it can happen at all frequencies depending upon the transfer function. So option is D, all frequencies.
So here the question is, calculate the effective inductance of the circuit shown below, and here the inductive circuit is given with three inductance, L1, L2 and L3, and the value of L1 is 4 Henry and value of L2 is 8 Henry and the value of L3 is 6 Henry. And if you observe the dot convention and the inductance 1 and 2, okay, the mutual inductance between 1 and 2 are 2 Henry, and these two are series opposing in nature, and these three are connected in series. That is the first point. And if you observe inductance 1 and 2, that is 4 Henry and 8 Henry, and these two are connected in series opposing, because if you send a current through this terminal here, okay, and the current will be leaving the dot here, but and entering the dot for the second inductor. So that's why these two are in series opposing. And if you observe the L2 and L3, Okay, there is then L2 and L3 are mutually coupled, but there is no coupling between L1 and L3, and the mutual inductance between L2 and L3 is 4 Henry. Now if you observe here, and the dot here, if you send a current of let us take any ampere, and the current will be entering into the dot for second inductance, and similarly the current is entering into the dot for the third inductor. So that's why here in between 1 and 2 inductance there is a series opposing nature. In between 2 and 3 inductance there is series aiding nature, and the formula for series aiding is L1 plus L2 minus 2m, this is for series opposing, and series aiding is L2 plus L3 minus plus 2m. Right, but here 3 inductance are given, so initially these are three in series. That's why L equivalent equal to L1 plus L2 plus L3. And now you observe here what is the mutual inductance. There is a mutual inductance between 1 and 2, but the opposing nature, so that's why minus 2 times the mutual inductance is here. Let us take M1, and next plus 2 M2. If you substitute here, L1 is 4 and L2 is 8 and L3 is 6 and M1 is 2, so 2 times the 2 plus 2 times the M2 is here 4. So if you solve this, you will get
Question is, two port networks are connected in cascade. The combination is to be represented as a single two-port network. The parameters of the network are obtained by the product of individual. Here, when two networks, that is network 1 and the network 2, if suppose these two are connected in cascade, means the output of the network 1 is given as the input of the network 2. Suppose N1 having a matrix and N2 is represented with a matrix T2, then the whole network is represented with a T, which is nothing but a product of T1 and T2, because individual matrices, we are assuming that those are T parameters, then only we can take the product. So option A is correct.
Here we have to find the value of the limit x tends to 8, x power 1 by 3 minus 2 by x minus 8. Now we'll use L'Hospital rule to solve this. So it is nothing but differentiating the numerator and denominator separately. So if I differentiate x power n, it is n into x power n minus 1, and differentiation of 2 is 0. By differentiation of x minus 8 is 1. Now as the limit is tending to 8, we'll substitute the value of x as 8, which is 2 cube. Now the value of the limit is 1 by 3 into 1 by 4, which is 1 by 12. That is option B.